Hi everyone, my name is Jagan. Today I'm going to talk about disk management in a Red Hat operating system. Generally, what happened is we generally deal with the disk management in terms of disk extension or disk reducing or creating the partition, uh, creating the partition and reducing the partition size and if any issue or if additional disk requires, then we request VMware team to to add the new disk. Likewise, there are certain activities that we perform in disk management. Okay, so just before I'll get into the disk management, I just want you to know about the storage. Okay, so what is the storage and what is the use of external storage? Though we have a ESXi host has a local storage. In spite of that, why we go for external disk? Okay, see the though the ESXi server has a local storage, but that storage isn't not enough to maintain the data. Therefore, we always rely on external storage. Okay, so the external storage can external storage can be let's say 100 TB or 1 TB or 1 petabyte, 1 zettabyte likewise, that can be extended. The external storage. Okay, as far as external storage is concerned, the storage capacity can be extended. External storage. Likewise, we can add the disks or uh, raw disk, so that the disk capacity can be extended. But when it comes to the storage, local storage, that cannot be extended. Therefore, moreover, there are advanced disks types we have, so that can enhance the storage capacity as well. Okay. Uh, Now, right now we have two types of disk. One is SCSI technology, and other one is SSD. SSD is this is the latest one, and this is the very fast and robust and high performance disk technology. SSD. SSD stands for solid state drive, and SCSI stands for small computer system interface. Okay, see, SCSI technology is old one. This is the old one. This is a latest disk. This is the latest one. That is the old one. And we have one more disk that is outdated. That is IDE. IDE. IDE is outdated one. So this is the So we have a generally currently we have two types of disks. One is SCSI technology and SSD. The third one is outdated, so we don't consider IDE as a disk. Currently in the market we have two types of disk. One is SCSI and another one is SSD. Okay, so this all are the disk. So generally, what happened is, as far as physical disk no as for no for physical servers, we raise a request form, and we raise a request form and send it to the storage team. The storage team, what the storage team does is, storage team allocate the some space to the physical servers. Okay, those physical servers, no, no the administrator, no, physical, the VMware administrators, what they do is they share the physical servers details like HPA call information and all. So the storage team, based upon the information given by the VMware team, the storage team allocate the space to the physical servers. That is the physical storage. But as far as the virtual volume is concerned, the Linux team will make request to the VMware team. The VMware team will allocate the space to the virtual machines. So they add the disk to the virtual machine, and in so they add the disk to the virtual machine. Inside the disk, OS Linux team create the partitions, like how number of the some certain set of the partitions are created inside the disk. Okay, so and okay, let's see how the connectivity is happen between the servers and the storage. I'll uh, I'll create the diagram. So here what happened is, so this host has a adapter, host bus adapters. This host bus adapter is designed to connect it to the storage switches. Okay, this host bus adapter is, each host has a minimum two host adapters. Okay, if one host adapter goes down, then we still have a one more host adapter to have a remain connectivity. So to have the remain connectivity to the storage box, we have a two minimum recommendation, minimum host bus adapters, number of the host bus adapters for the servers is two minimum, because to avoid any outage, if any storage disconnectivity happen, then we still have a one more connectivity through which we still have a connectivity to the storage. Okay, so this is how this connectivities happen. So this host bus adapter connect to the switch, SAN switch, and SAN switch again. See, this one cable is connected to one switch, another cable is connected to one more different switch. Here the switch number of switches also recommended to have a two. Okay, the number of switches uh, to be configured here is two, because if one switch goes down, we still have one more switch. Okay, so for redundancy purpose, we should have always minimum two. Okay, if more than two is configured, then it's okay, fine. But the minimum the recommendation is minimum two. And okay, and this switch is again connected to the storage box. Okay, this is storage box likewise. So the cables uh, cables can be FC cables, or normal cables. Generally, few people, if it is FC is too expensive, therefore they don't fiber channel cables are not preferred. Therefore, normal cables are preferred to for connectivity from the servers to the storage. Okay, if it requires too much speed and maximum speed, if it requires, then it is good to go FC cables, fiber channel. Okay, So this is how, and the storage team here, this is the so here uh, storage team, what the storage team does is storage team allocates some space to the host. Okay, so they allocate the space, and they once they allocate the space, they create the one logical number. That logical number is LUN. Okay, LUN, logical. Uh, okay, this number logical unique LUN is created. Okay, and this number is given to the uh, VMware team. So the VMware team, based upon this LUN number, they will scan the storage and identify the storage, the volume. Okay, and after that volume, then in that VMware vSphere, they create the data store, and after that after the data store creation, then whenever the OS team, either Windows team or Linux team, ask space for space, then the VMware team assign the disk to OS, either Windows or Linux. So this is how the storage connectivity and adding the disk to virtual machine. I'll talk about the more in detail about the management of the disk in Red Hat operating system. Okay, so here the things that I'm going to talk about. Okay, so this we have discussed the disk. Okay, so disk, how the storage connectivity happen from the ESXi server to the storage box. Okay, so generally the disk is nothing just a collection of platters. So inside the disk we create the partitions. Okay, so before I'll see the how to what are the things that we are going to discuss. One is creating the partition inside the disk and deleting the partition inside the disk. Okay, so uh, next one. So generally, the partitions are created inside the disk. Okay, so the once the disk is added to the virtual machine, then we create the partitions inside the disk. Okay, now generally we have three methods to create the partition. The first two method we'll talk about the normal method. Okay, today I'm going to talk about the normal method, how to create the partition using a normal method, the basic method. We still have one more method, that is LVM. Okay, logical volume manager. With this we can create the partitions, but let's see today the basic method, how to create the partition with a basic method. Then in the next class we'll see how to create the partition in with LVM. Okay. I'll also see what are the differences between basic method and LVM, advantages and disadvantages uh, with two methods. Okay, so generally uh, using normal method. Okay, using normal method, we can create 64 partitions. partitions. Okay, using normal method, we can create 64 partition. With the LVM, we can create 29,932 partitions. T. So using normal method, we can create 64 partitions. With LVM, we can create maximum 29,932 partitions. Okay, and I'll also talk about the different major advantages of LVM method. Okay, so generally, we create in the normal method, we create the four primary partitions. Okay, uh, primary partition and logical partitions. The primary partitions, uh, why we create the primary partition? What is the use of primary partition? What is the use of logical partition? Let's say, see, I have a one disk. Let's say example. Generally, the disk will be in the form of, let's say, so okay. So first disk, how the disk looks like. Let's say in the Red Hat operating system, lsblk. Okay. See, this is the SDA is the disk. Okay. Starts SDA, SDB, SDC, SDD, likewise. So if you add the disk, then the disk will be look like SDA. If you add SDB, and these are all partitions. Okay, type you can see here the type disk and partition. Inside the disk, we created the partitions. We created three partitions: A1, A2, A3. These are the partitions. And B disk, we have a one partition, that is LVM. Okay, so LVM, we have created the partition. Uh, so we'll see the display partition types. Okay, see type size. Okay, disk size, total how much disk. SDA1, this is a 599 MB, and this is a 1 GB. Okay, around after, so out of 1 GB, 260 MB used, still to 755 MB is left. Okay, this disk is for boot, and this disk is for home directory. Like this, we can see the disks and disk space and how much is used, a while, and percentage wise also we can see, right? Now, okay, we'll see the what is the primary partition, and so we can see this is our primary partitions. Okay, sorry, slash boot. Okay, slash boot is this directory is, as I said earlier in first class, this slash boot directory is used to store the bootable files. Okay, this is we can call it a primary partition. So in a disk, in a single disk, we can create maximum four primary partitions. So the primary partition, this is a, so each primary partition is primary partition store bootable files that are executable programs. So this primary partition is not suitable for storing the data. So for storing the data, we have a logical partitions. Okay, primary partition. So a primary partition is having the primary partition is to pri- so is to store the to store or to run the bootable files or executable programs that will help the OS to run. Okay, so main intent of the primary partition is to store the executable files. When it comes to logical partition, to store the data, logical partition is used to to run the any programs or bootable files. Primary partition is used. Okay, so how the disk looks like, for example, SDA. SDA, let's say this, let's say we have added the disk one SDA disk. Inside the disk, we can create the partitions like SDA, SDA1, SDA2, SDA3, SDA4. Likewise, we can create the partitions. So in every disk, we can create until 64 partitions. Likewise, SDA4, SDA, so dot. You can create SDA 64 partitions. Okay. Likewise, inside the disk, how many partitions can be created is 64 partitions. Okay. So, but here it is allowed four primary partitions. Primary partition. So in each disk, we can create 64 partitions, normal method, and out of 64 partitions, we can create three primary partitions, one logical partition. This logical partition is used to extend the disk. Okay, for example, likewise, this is the disk one. Wait, disk one. So likewise, disk two is the. Likewise, we can create the partitions inside the disk. So here, why should we create the logical partitions? Is see three primary partitions and one logical remaining all logical partition. For example, let us say I have one disk. Okay, I have one disk. The size is, let's say, 2 TB. Okay, so I have the disk, that is the size is 2 TB. This disk size I split like SDA1 equals to 500 GB. Is SDA2. This is 500. So here SDA1, 2, 3, 4. Okay, all are primary partitions. So here, though we have created the partitions, but here, if we create the partitions like this, all are primary partitions, then the space that we have utilized is only 1 TB. Remaining 1 TB is unutilized, unused, and it goes waste, right? So therefore, this kind of partition is not recommended at all. So since no, this type of approach is not at all suggested, because we still have a 1 TB that is unutilized. Therefore, to make use of that remaining 1 TB, okay, the above uh, met above type of disk partition is not suggested, as it is as it uh, since it is un, unutilized. See, this partition is not, since it has unutilized space. So therefore, the right approach is, let's say, 2 TB, STA1 500 GB, STA2 500 GB, SDA3 250 GB, SDA 750, SDA4 750 GB primary. So here 5 500 GB, 500 GB, 250 GB. These three disks are created as a primary. The remaining disk is created as a extended because out of 750 GB, this 750 GB completely can be utilized. Like how we can be create. Okay, STA 5 100 GB logical, STA 6 250 GB logical, SDA 7 500 GB logical. So likewise, we can use the remaining space. So this is how we can utilize the complete the space in a disk. Okay. So likewise, we can create 64 partitions. So this above the above disk partition is recommended. See, this kind of disk partition is always suggested because no, it is utilized a complete disk space. Okay, here we are not using the remaining space. Okay, so 1 TB is 1 TB goes unutilized. Therefore, the best disk partition is to make use of the three disk as a primary, and the one disk one partition as extended. After extending, then we can create a logical partitions. So this is how the disk partition should be done. So this approach like three primary partitions, and after that extending this kind of the partition is suggested, recommended, since we can utilize the remaining space also. Okay, now we'll see, let's create the partition inside the disk. Okay, so so if we have a space in a disk. Okay, for example, LSBL. Okay, see see this SDA1, SDA2. Okay, SDA1 is 1 GB, okay, size, and the used space is 260 and available space is 755 MB. Okay, still we have a 755 MB. So if we have a space, then we can create partitions inside the disk. Okay, If we don't have the disk, then we have to add the disk. After adding the disk, then we have to create the partition. Okay. Right now I just added the disk, but here it's not showing the disk. LSBLK. So here only is showing SDA and SDP. After adding the disk to reflect the disk at the OS level, we have to issue the one command. Okay. So how to what is the command to reflect the disk at the OS level after adding the disk is echo 2 greater than symbols slash sys class scsi hyphen host 0 slash scan. So if we don't find a disk, now we have to issue the commands until until disk is reflected. Yeah, you can see the disk is added. Now see, we have added the disk. So likewise, to reflect the disk at the OS level, we have to issue the command echo double inverted commas and three hyphens greater than symbol sys class scsi host 0 scan. Okay. After issuing this command, if you check lsblk, we can see the disk 10 GB. Okay. So I'll write in a note. So here generally we can run until 32 channels. So through 32 channels we can see and no and no try to reflect the disk at the OS level. So generally what happen is one or two channels the disk that we have added at the OS level will not be reflected. Therefore, sometimes we may be required to pass the to open the channels around 4, 5, 6, or 7. Therefore, to reflect the disk at the OS level. Okay. So issue this command echo double inverted commas and hyphen three hyphens two greater than symbols and slash sys slash class and slash scsi host and slash host for scan. Okay, excuse me. Okay, now we got the new disk, that is a SDC. Okay, inside the SDC we will create the partition. Okay, so first step is creating the partition inside the disk. Okay, now we the first what is the command to get into the disk is f disk slash dev slash sdc. Okay, now we are in the disk SDC. Here it's showing welcome to F disk. Okay, and it's showing here command M for help. So if you press the letter M, then you will see a lot of options like uh, so N is to create the partition and P is to print the partition information and W is to write the content to the disk. Q is to quit. Okay. So these all are options use uh, we can use to create the partition. So what is the command to get into disk? F disk slash s slash dev slash sdc. So we are creating the partition. So I've shown you. I'll list out the details in a notepad. Okay. P is to print the partition information. Okay, let's see the P and enter. We'll see the partition information. SDC 10 GB. Okay, and sectors 512 bytes. And the sector is what is the sector is half byte. Half byte we can call as a 512 bytes. This is called as one sector. Okay, and disk type DOS, disk identifier. This is all information about the disk. Okay, so we haven't yet created the partition. It is showing the complete disk. Okay, we have added the disk 10 GB. It is showing in bytes. Okay, here 10 GB here SDC and bytes. The number this is in bytes. Now uh, let's create the partition. So to create the partition, we use the option is N. Okay. So here, once I enter the letter N, it is giving me options primary and extended. Okay. As I said earlier, primary is used to store the bootable files or programs. So to store the bootable files or programs, primary partition is used. Okay, to store any data or log files or any a kind of the data, we use the logical partition. Now I want to create the one primary partition. Okay, so to create the primary partition, we can enter the P and enter. So here asking the partition number 1 to 4. Okay, so let's say enter the 1, and the first sector it is by default it taking the uh, uh, taking the date size. Okay, so 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 here I'm uh, I'm going to create the primary partition, the how much is space. Okay, so let's say I want to create a out of 10 GB. Let's create a 3 plus 3. So here it is showing created a new partition of type Linux size 3 GB. Okay, now we'll see the partition information. See here you see the first partition is created 3 GB. Okay, I created here 3 GB, the first partition. Now I want to create the one more partition. And so here now it is asking, now see, if you see here, one primary is completed. Out of one, then we have three. Okay, now I want to create a extended partition. So uh, so if you want to create extended partition, enter the letter E. After entering the letter E, enter. Now we got a 2 to 4. Okay, so let's enter the letter 2, and so default is from here 6 to 3504, 503 end. Okay, so 482 503, this is the end. We have taken 8 GB, sorry 3 GB. So this is the sectors. Okay, this is end. Now it starts from 5042 at the end. Now how much the GB I want to create for extended partition. Okay, so for extended partition I want to create, let's say 4 GB plus 4, sorry. So here how much space we should take. Default, this is the complete space, out of which we have taken 7 GB. Sorry, 3 GB. Out of 3 GB, 10 GB is for primary partition. Still, we have 7 GB. Okay, out of 7 GB, I would take around uh, 4 GB plus 4G. Okay, now you see create a new partition 2 of type extended of size 4 GB. Okay, if you see the partition information, let's print enter. Now if you see SDC1 start from 2048 to 503. So the size is 3 GB. Okay, now SDC, the second partition is start from 504 to 111 last. Okay, and so this is a 4 GB. So likewise, we can create the partitions. Okay, now so we have made the changes. So if we come out of, if we exit without saving the changes, then there will be no partitions. So let us save the changes W. So the partition table has been altered, see, and the changes have been made. Okay, now let us so this is, now we have come out of the disk partition. Okay, so to so ls blk grep, see, sda, sda2, sda3, sdc1, sd2, we have made two partitions. Okay, you must understand. And see, uh, see, this is a disk sdab, this iPhone. If you see here, sda1, sda2, and so we to reflect the disk here, we still haven't mounted. Okay, so until the we still have a few more procedures to follow. So once disk partition is created, once the partition created inside the disk, we have to inform the partition information to the kernel. Okay, so what is the command to what is the command to pass the information to the kernel is part probe slash dev slash sdc. So we have informed the partition information to the kernel. Now after information to the kernel, we have to format the partition. Okay, so we have different types of format versions for file systems types. For example, we have a ext2, ext3, ext4, and xfs. So these all are types of the format. So we can make use of any one. Each format type has its own advantages and disadvantages. I'll list out in a notepad. Okay. Now, what is the command to uh, format the partition is? We have two ways. Okay, two ways to format the partition. One is mkfs mkfs hyphen t ext4 slash dev slash sdc1. So here, if you see here, we have formatted the partition with a ext4. Okay, we have one more disk. We have one more partition that can be formatted with a different file system type. Okay, xfs mkfs hyphen t. Okay, now we'll use a different method. xfs slash dev slash sdc2. Okay, so this is a different method. There is a different method. We can make we can make use of anyone. So here, see, appears to contain a partition table loss to force the overwriter. Okay. Okay. Okay, now we have formatted the partitions with the file system ext4. Okay, now we'll create the mount point and mount the partition to the directory. Okay, so next step is creating the mount point mkdir slash data. Now mount slash dev slash tc1 slash data. Now it is mounted. Okay, so change directory slash data. So you can write. So see, uh, until you mount the partition into the directory, you cannot write the data inside the partition. Therefore, to to write the data to the partition, we should at least mount the partition to the directory. Okay, this is a temporary. So to make this partition permanent, okay, we have to update this file system details in one more file, that is slash etc slash fs tab file for permanent mount. Okay, we this is a temporary. Okay, this is a temporary temporary mounting. To make it a permanent mount, we have to use the we have to update in a slash etc fs tab files. Okay, so how to update the slash etc fs tab file? Vi slash etc slash fs tab. So we have a see we have already few of formats information. Okay, so now we can use the insert slash dev slash sdc1 slash data ext4 defaults. I'll tell you what is this all about. Okay, 0 2. Now this partition is become the permanent. Okay, now we can write the data into the partition. Okay, now what are the steps? This is how we can do the partition inside the disk. I'll write in a notepad for better understanding. So the first step is to create the partition inside the disk. How to create the partition? The first step is create create partition in a disk. So how to create the partition first? Creating the partition inside the disk, we just get into the disk. So what is the command to get into this? F disk slash dev slash sdc. Okay. After getting into the disk, we can see the few options. Okay, like n. Uh, okay. Uh, if you enter the letter M, we can see the number of options like P, N, D, W, Q, L, and all. So what are the those letters information? Okay, so N is to create a new partition. Okay, P is to print a partition details. Okay, and D is to delete the partition. Partition. W is to save the partition, and Q is to quit partition without any changes. Okay, so these are all options we use in a F disk, in a partition. Uh, so next step is, okay, we create the partition. Okay, after creating the partition, we have to inform the partition information to the kernel. Okay, update update the partition info to kernel. What is the command to pass the information about partition information to the kernel? Part prop slash dev slash sdc. Okay, after that, what's the then we have to format the partition, right? So we we create the partition, we inform the partition information to the kernel, then we have to format the partition with the file system. What is the command? Mkfs dot ext4 slash dev slash sdc1. Okay, this is one way. Then other way is or mkfs hyphen d ext4 slash dev slash sdc1. Okay, so this way we can format the file system, and after formatting the file system, we have to create the mount point. Okay, create the mount point and mount partition to the directory. How to mount? Okay, first we create the directory mkdir slash data. Okay, so we have created the mount point. Mount point is a directory of both the same. So after creating the mount point, we will mount the partition mount slash dev slash sdc1 slash data. Okay. One more thing is until you create the mount and mount the partition to the directory, the data cannot be returned to the partition. Therefore, it must be mounted to the directory. Okay, this is a temporary mount point. Okay, to make it permanently mount point, we have to update the this information files is this information fs tab file. Okay, so update the file system details in slash etc slash fs tab for permanent mount. Okay, for a permanent mount we use we have to update this file system details in slash etc fs tab for permanent mount. Okay, so what are the details we should update here is slash slash dev slash sdc1. Okay, and slash data and ext4 and defaults 0 and 2. Okay, see, this is the slash dev slash sdc. One is a partition name. Slash data is the directory name, and slash ext4 is a file system type. File system type slash sorry defaults is the permissions. Okay, permissions and 0. I'm 0 is 0 is the backup checking the backup whether 0 is not required, 1 is required. So here if you mention the digit over 0, then backup is not required. Backup checking not required. Here 2 is file system checking. Okay, for example, when the file system checking is done happen because during the server booting time. Okay, when the server reboot or when the server starts, okay, the file system checkup is done. So if 2 is mentioned, then last checkup. If the 1 is mentioned, first. If 0, no file system checkup is required. File system checking. Okay, so this is how we can create the partition inside the disk. Okay, so creating the partition inside the disk. After creating the partition inside the disk, we no we get into the inside the disk. After getting inside the disk, we have a options like a new partition, primary partition, extended partition, logical partition, or delete the partition, save the partition and all. So after the partition details, we exit, we come out of the partition. After that, we inform the disk information to the kernel. Okay, after informing disk information to the kernel, we format the partition with the file system type. Okay, so here the file system type, I just missed it here. We have a four file system types. File system types. ext2, ext3, ext4, and xfs. This is the latest one. Okay, so the file system, these all are as Red Hat released the latest versions. The file system types also have been changed. Okay, so this ext4, it suppose the uh, uh, it ext4 is Red Hat REL6, I think RHEL6, and this one RHEL5, RHEL4. Now this one is RHEL7 and 8. So XFS file system has many advantages as compared to ext2, ext3, ext4. Okay, so this so and it has a file system, individual file system size is 16 GB. I know ex for ext4, 2 TB, sorry, 16 TB individual file system size. For example, I want to create one partition which is sized around 16 TB. So ext3 file system format is not supported. Therefore, but we should go for ext4 because ext4 suppose 16 TB individual file system. It suppose individual file system 16 TB size. Okay, so and that is different types of file system types. So I hope this is very helpful. Creating the partition inside this is a basic method. See, we don't use this basic method, but use very rarely. But most of the time we use the LVM method. The partition using LVM method is preferred uh, rather than basic method, because LVM, creating a partition with LVM has more advantages over basic method. Okay, so but these, what are the steps that we have performed so far? All are important because in LVM around 3-4 steps are followed in creating the partition with LVM. Therefore, I have discussed this partition disk partition using LVM, sorry, basic method. So thank you for watching, and keep watching my videos. If I have missed, or if you want to know, if you want me to cover any points and all, please leave in the comments. Thanks for watching. Have a nice day.